with the advent of synthetic pesticides in the early 20th century, humans made significant progress in their efforts to control insects, plant pathogens, and other pests that can drastically reduce the yield of agricultural crops and threaten human populations. In particular, early success with chemicals such as DDT, for which Swiss chemist Paul Muller won the 1948 Nobel Prize in Medicine, effectively diminished the number of harmful insects that had plagued humans for thousands of. 2-DDT was widely applied across the world throughout the middle of the 20th century. Its effectiveness against a range of arthropods was celebrated. It contributed to the reduction of malaria-carrying other insect vectors and used extensively to control pests that threatened agricultural crops. However, shortly after the initial decline in pest populations, a noticeable drop in efficacy was observed, and consequently, agriculturists were forced to increase application rates to meet past levels of control. Agronomists later determined that persistent use of the pesticide had resulted in its reduced effectiveness by killing off natural predators and generating more resistant pests. 3. When a broad-spectrum pesticide like DDT is applied to a crop, it usually kills the vast majority of target pests, but a naturally resistant portion of the pest population survives. Often, the net effect is a subsequent increase in the number of resistant pests, followed by increased resistance in successive. For an example can be seen in the cotton industry in the southwestern, where pink bollworm populations were successfully controlled by DDT in the early 1950s. Soon, however, their numbers exploded because naturally resistant survivors had no predators. Area wasps that prey on the pests were virtually wiped out by DDT. Farmers responded by repeated applications of the pesticide to try to control the bollworm. Ironically, this created a cycle known as the pesticide trap, where survivors pass on their intrinsic resistance, creating even stronger offspring genetically predisposed to successfully coping with the pesticide, a process that can occur rapidly among prolific reproducers. Accordingly, this human-induced resistance meant that farmers were devoting finances to a pesticide that was slowly ruining the regional cotton industry. 5. Resistant populations, however, present just one of the adverse effects of using broad-spectrum pesticides like DDT. Misgivings soon developed among environmentalists on other organisms, such as birds, fish, and mammals. Moreover, concerned scientists began to realize that these chemicals were not only toxic at the point of source, but that the toxins could end up polluting lakes and rivers due to agricultural runoff. DDT, for example, was blamed for a pronounced decline in bird populations. It was later learned that decades of spraying DDT had created toxic concentrations of chemicals in the tissues of higher organisms through biomagnification, a process where toxins occur at higher intensities as they move up the food chain. It increasingly seemed that its continued use was no longer justified. As a result, DDT was banned for most applications in the United States in 1972 and has since been regulated in many parts of the world. Their most powerful pest control tools, and agronomists were faced with stronger pests and the challenge of moving beyond reliance on a single broad spectrum. Chemical. In many agricultural regions, a popular response has been to institute a method of pest control that utilizes a variety of different pesticides. The measured success of this multiple attack approach is contingent on the use of pesticides that employ dissimilar modes of action to attack pests in distinct ways. One technique to maximize the chance of success is to apply a mix of various pesticides at the same time, with the hypothesis that if one means of attack fails, another will work. Also, pesticides can be used in rotation or sequence. For instance, one insecticide can be designed to attack insect pests in the larval stage, and another can be formulated to exterminate reproductive adults. The idea is that pests will have greater difficulty developing resistance to multiple chemicals, and that using them in combination or in turn will prevent any particular one from entering the environment on a large scale at a given time. 7. However, skeptics emphasize that this method also necessitates the continual application of artificial, and that the cumulative effect of these chemicals on ecosystems as a whole is still poorly understood. They point to DDT as an example of a past solution that was originally believed to be sound, turned out to have unforeseen dangers. In reaction to these concerns, more and more agriculturalists have turned to integrated pest management as an alternative. The integrated approach greatly reduces dependence upon chemical pesticides and draws upon biological, cultural, and mechanical controls. Introducing natural predators, such as ladybugs, beetles of the genus Coccinelle, to prey upon unwanted insects, planting crops early in the season before pests reach peak numbers, erecting physical barriers, and placing insect traps. All of these represent organic forms of control that complement the use of chemicals, thus limiting detrimental ecological effects resulting from